Still you're blinded by the lies, so you can see what you do. Restless every time we start locking as a lost control. Oh, it's paradise with honesty, but I'm in the dead of the night. Teardrops on the floor. The pain is over. Feel the darkness take control.
When the lights go down, I've seen hell in you, but you don't care, no, you don't care, no. You just rather watch me fall from a quarter mile. I can see you at the call. Think about it, ring won't tell you what I saw. When you break it off, you'll see who had it all. You had it all. You said you wanted to fall into oblivion. Forget about the world we're living in. Fall into oblivion, oblivion. Oh, yo. Fall into oblivion. Fall into oblivion. Forget about the world we're living in. Fall into oblivion, I'm going on. You can't fall asleep when you're counting stars. Get it together. Your mind can't sleep when you let it starve. But now you wanna see me fall from a quarter mile. I can see you at the call. Think about it, ring won't tell you what I saw. When you break it off, you'll see who had it all. You had it all. You said you wanted to fall into oblivion. Forget about the world we're living in. Fall into oblivion, oblivion, oblivion.
fate. Hesitate to give me some, I'ma catch a murder hit. On my clock, in this cop, mask on my face. Hesitate to give me some, I'ma catch a murder hit.
Fly away. It's the first time of today. Today. To dream, believe. You are the strength, you're all I need. Need. Oh, gonna give it a shot. Only one of me to shield you all from the enemy. You're a superhero. You're a superhero. Can I be your superhero? Superhero.
All right. Hey, everyone, and welcome back to our yet another session on this is part of our Kubernetes masterclass. And we're going to get started with our fifth masterclass and the fifth mission that's going to be about deployments. So let me actually just begin by recapping. And we're coming back after one week's gap, actually. So last week we I was also traveling, not doing very well either. I had asked you to focus on the projects. And those are you who are part of the hackathon or the Kubernetes dojo. You might have spent some time catching up with the things from earlier and working on the project. And this is where we stand right now. We started with the first mission being containerization, where we talked about how do we build container images. We talked about how do we run the pods as part of a second mission that was our podification. The third mission was scalification, where we talked about replica sets, namespaces, and auto scaling, the horizontal pod auto scaler. The last one, we talked about network, and how does Kubernetes network, the lower level network, the higher level network, the service networking, and all the interesting stuff related to that is what we talked about with load balancing and different types of services. We talked about ingress as well, which was another interesting topic that we took. Today, we continue on that journey, and we will be talking about a couple of main topics. One would be about deployments. How do we roll out the application? How do we roll back? How does that work? and what Kubernetes offers, what it does not. So we'll discuss all of those things, and we'll also talk about a little bit about configuration management with a couple of objects there called as config maps and secrets. And then we will come back next week and talk about persistent storage. That's when I'm going to move the daemon set and stateful set together because this is quite related to each other. So we'll talk about it during the persistent storage, the next mission. Then we talk about security, HEM, production cluster, a bit of administration, and then Argo CD, right? So that's the order which we're going to go in. Now, when we talk about deployments and Argo, it has some sort of an relation to each other, because what is not offered by the deployments in Kubernetes is where we take up the Argo CD as well, right? So that's where we're gonna get started with. So are you ready to get started with the deployments today? It's been a gap of those of you who have been part of this 90-day challenge. It's been a gap of a week. I think it's not a really good idea to take a gap or a break from next hackathon onward, next quarter onwards. We'll avoid doing that actually. Right. So let's get started with our today's session where we're talking about deployments. And I'll start explaining things to you and also demonstrate it to you through this example that we have started with. So we have so far deployed the application with the replica set and exposed it using service as well as ingress controller. So if I go back to my setup here, this is what I have so far. I have, cleaned up this a little bit, but basically I see a replica set for this application called as Vote, the front-end application that we have, started with talking about. This is a application stack. For those of you who are completely new, we are working on this particular microservice stack where we have 5 services: Vote, Redis, Worker, DB, Result. One is Python, second is a .NET application or a Java application. Another is a Node.js application. And we have a couple of backing services in the form of Redis as well as Postgres database, right? So this is what we're deploying. And what you see on my screen right now is a couple of those applications, Vote and Redis, being deployed. Both have services. One has a deployment. That's what we're going to talk about. One has been deployed using just a replica set, that is this Vote application. So when we talked about the replica set in the mission number 3, we looked at what it is capable of. Replica set does 2 things, actually. It gives you 2 features. Can you name any of this? Can you put it in the chat? What are the 2 features of the replica set? What does it do? And then it does not do one thing, and that's where we bring in the deployments. All right, anyone on the YouTube stream, on the Zoom chat? All right, I see Pradeep, Devish, Rajni, Giri. There's okay, scalability is one thing, Pradeep. Yeah, perfect. Scalability is one thing that replica set offer. What is the other thing? It is one of the abilities. It is high availability. That's correct, Devish. So replica sets are capable of offering 2 things. One is the scalability, so that you can define the scale. Here I have defined the scale of 4, and it has made sure that 4 replicas exist. It also gives you the availability, as in, oh, if I delete something, it is going to ensure that it always comes back up. I can show you for an example. Let's say any of these pods. If I look at the age of the pod, like I'm going to delete this pod, which has been there for 13 days. This has been there for 20 days. And as soon as I delete these 2, it's going to bring up the pods again, right? So you can see that it just brought up 2 of these pods, and you can keep doing that as many times as you want, and it's gonna just bring it back up basically. So replica sets offer us the availability and the scalability both, right? What it does not do though is it does not take you from one version to another. So it doesn't do the application rollout. on its own automatically, that's when we need the deployment, right? So let me explain these concepts a little bit through this visualization, and then we'll understand how the rollout actually happens. So when we use replica set, it gives us two things: the scalability, where you define the number of replicas. This is the property that you add in the YAML as well, that number of replicas. You set it to some number. Let's say I've set it to 4. And then it also gives you the availability, as in when you delete something, it always makes sure that it is brought back up. We've seen that just now. What it cannot do is go from one version to another. If you have to do that purely with replica sets, you would have to basically delete this replica set and create a new one. And that could be a manual process. Or you would have to use something like a deployment, which ensures that it give, I mean, in addition, deployment is nothing but, let me bring up one of my presentations. I don't have it here. So what is a deployment? Deployment is nothing but you take the replica set, you add the strategy, and you get something called as a deployment here. All right. All right. So this is where we are at. Replica sets work with the selectors. So you have the labels associated with the pods, and the replica set will basically identify the set of pods that it has to manage using these selectors. That's how it keeps those many replicas alive and all that. Now, we've talked about this earlier in mission number 3 when I spoke about replica sets, that this is a difference between replication controller and replica set. With replication controller, you only get those two features, availability and scalability. It doesn't even give you an ability to add any strategy or anything like that in the YAML format. Whereas replica sets allow you to do that, provide the update strategy, which is nothing but a strategy to go from one version to another. And when you add that, you get a deployment. So deployment is nothing but a replica set, but plus it's just a superset of replica set. So you take the replica set, you add the update strategy, and you get the deployment. Even if you look at the spec, and replica set maintains the set of pods using a template. So that's where the pod template, that's how it looks like. You can think of deployment is a superset of everything. Replica set, which maintains the set of pods, and then you add the update strategy. So if you look at the spec as well, you take the replica set, you add the strategy part, and you get the deployment spec that way. So how does it work, and what is the deployment spec actually? Let's have a look at that as well. So let me take you to the API reference and show you what is part of the replica set spec. And it contains this minimum ready seconds, replicas, selector, template. Template is the pod definition or the specification. So replicas is responsible for the scale, the scalability aspect. So you define the number of replicas, let's say 4, and it ensures that pods are created using this template, and there are 4 number of pods maintained. How does it know how many are there and whether they're running, matching the desired count, which is the number of replicas or not, is is defined or determined using the selector. So replica set uses a selector, which is like a filter, to watch for X number of pods with certain properties. And if it finds those many matching the number of replicas, it is happy, right? So that's all it cares about. If you look at deployment spec, it has everything that the replica set has. That's why this diagram, it has everything that replica set has, plus it has a few more, including the strategy. That's when you see minimum ready second, replicas, selector, template is already there. There are a few more properties. The main here being the strategy. The strategy is where you define how to go from one version to another. So what are the strategies which are supported? There are 2. One is recreate, second is rolling update. Rolling update is the default anyways. And if you use rolling update, there are a couple of properties, max search and max in available. Now, what is this recreate and rolling update? What is the difference between these strategies? How will it roll out if you use recreate versus if you use, let's say rolling update? Let me explain that with an example as well. We're diving into that now. So let's say you have an application with version 1, right? And what you do when you create a deployment is you take the replica set spec, you add the strategy, and you basically get the deployment.yaml. Now, what could be the strategy? It could either be recreate or rolling update. Recreate is a very simple strategy where you bring down the replica set. Basically, it works with the replica set. Deployment internally creates the replica set and maintains multiple versions of those. We'll look at that as well when I demonstrate it to you. And what happens here is it creates a new replica set, mapping new version, and it goes from one version to another with a downtime, basically. So there is a downtime in between, and then it goes to the next replica set and it declares it being rolled out actually, right? That's what a recreate strategy would mean. Whereas rolling update is also called as a zero downtime deployment strategy, where it rolls out in batches actually. How will it do that? Is it instead of bringing everything down, let's say go from version 1 to version 3, there would be a new replica set for version 3 as well. And what it will do is it will not bring down everything at the same time. It will do it in batches. Let's say batch of 2, like 50% in this case. And then let's say 2 have been rolled out, 2 are with the older version, 2 are with the new version. So at this point of time, there could be 2 different versions available, but there would not be a downtime, right? And that's what is happening here. And then it waits for some time, and then it waits, rolls out the next batch, and basically it declares it as being rolled out. So this is why it is called as a zero downtime, because there would not be a downtime while the rollout happens, unlike recreate strategy, right? So how it ensures that the batch size is defined and how it ensures the this zero downtime deployment is where it has these 2 properties, max unavailable and max surge. So I showed you the spec here where we have rolling update. Rolling update has max surge and max unavailable. And what happens there is basically the way this works. Both of these properties work towards the batch size. Batch size is how many pods are replaced at any given point of time. Why do we need 2 different properties? Let's understand with that with an example here. Okay, so let's say we have 8 pods which have been rolled out with version 1. So version 1 is running 8 pods, right? Now we want to deploy the version 2. So when you look at the pods, you're going to see 8 out of 8 running. Like I see here, 4 out of 4 running. So how many are there? We typically can find out by looking at get all. So deployment wise, just 1 out of 1 running, right? So it will be 8 out of 8 running in this example where we have, let's say 8 pods running with version 1. Now, let's also think about how many requests can it serve per second, right? So let's say we have every pod serving 10,000 requests per second. And that's the capacity that it has, right? And let's assume that this is our production deployment. And we may need some capacity to be available at any given point of time in production like environment, right? Let's say this is our real application with real customers. And let's assume that the minimum guarantee for the capacity that we need is 70,000 requests need to be processed at any given point of time, no matter what. What that means is out of these 8 pods, 7 have to be available at any given point of time. Now, if 7 have to be available, that's what this max, I'll come to that. So 7 have to be available. 1 can be taken down. 1 can be made unavailable or taken down. And that's your max number of unavailable pods that you define here. So to ensure the guarantee, minimum guarantees, you define the max unavailable. So max unavailable, if it is 1, it guarantees that 7 would always be available. Only 1 can be taken down, and that becomes your batch size if there was nothing else, right? This would have been a batch size of 1. Now, the issue with this is if there was a batch size of 1 and you have, 20 pods or 30 pods, it's going to take like, a long time to have everything being rolled out, right? So it's going to take work in batches, and it's going to work in very small batch now, and that would take longer. So how do we reduce that time during the rollout is where we add something called as a surge. Now, what is this surge? Surge is just nothing but you add few more pods during the rollout just to speed up the process. So max unavailable is responsible for the minimum guarantees. And to speed up the process, we add that surge. How much of surge? Maximum of, let's say we say 2. So that becomes our max surge, right? And when we create a surge, what happens is when you're rolling out a new version, it is created with the new version, the new pods, just pods which are created as part of the surge. And then it starts rolling out in multiple batches. And your batch size now becomes the 1 plus 2, max and available plus max surge. So 1 you can take down anyways. Out of 8, 1 can be taken down, which still gives you guarantee of 70,000 request and 7 pods being available. And then you create a surge of 2. So in total, you can actually replace 3 pods or work in the batch of 3 here, right? That becomes your batch size. So max unavailable plus max surge is your batch size actually. And then you basically created surge of 2. Max unavailable give you 1 to be brought down. So you have a batch of 3, which is now running with the new version. Let's say version 2 with this new replica set. How different versions are maintained are with different replica sets, and I will show you that shortly. And now what happens is we have rolled out a batch of 3. Then comes the wait period. So after you have rolled out the first batch, you don't want to immediately start the rolling out of a next batch, because you want to ensure that everything is stable enough, right? Because sometimes what happens is, oh, everything is fine, the health checks pass, but when the actual traffic is sent, this is the time when the traffic starts being sent to the pods as well. They become ready. Once they are ready, they start receiving the traffic. Now, after receiving the traffic, what happens is sometimes the application may crash. So you want to ensure that you give it some time to stabilize and make sure that you watch it, that nothing is crashing. And that time is what you can configure as the min ready seconds. One of the properties which we did not use as part of, it was part of a replica set as well. You can see that with replica set min ready seconds plus deployment, it has that. So when you actually use deployment, you start using min ready seconds. Now, this min ready seconds is nothing but this interval where we say that, hey, everything is stable, but we still want to wait for 20 seconds just to ensure that, we're not crashing the pods and everything is looking all right, right? That's the interval that you define. In the second, the unit is already given. So min ready seconds, it's in the seconds. And then you wait for 20 seconds and then go with the next batch where you can work with the batch of 3. And at this point of time, when you see this, these 3 are being brought down, you still are meeting the minimum guarantee because you're working with a surge of 2. That's why you can take these down. 1 you can anyways brought down. So basically, 4 plus 3, you still have the minimum guarantee being met here, 70. And then this gets replaced with a new version, and that becomes your second batch. And after this batch, it goes, waits for 20 seconds, and then goes and rolls out in the next batch, which would be, let's say, 2 more. Now, what happens at the end is, since you created the surge of 2 with the new version, it doesn't have to roll out anymore because 8 are already available. 8 is what you need. These 2 will just be deleted as part of the next batch, basically. And then it considers that it is being rolled out. That is how the rolling update, the default kind of a deployment, works in Kubernetes. That's what I'm going to demonstrate to you now. And what I will begin to do is first, I will convert the replica set because everything right now related to that vote application is being run with the replica set. I'm going to convert that into deployment. And as I said, replica set is nothing but you take the replica, deployment is nothing but you take the replica set, add the strategy, you get a deployment. That's what I'm going to follow now. So I have a code here. You will have access to the lab guide as well. I will share that with you at the end of the session. So don't worry about it. You'll have access to the lab guide. So whatever I'm demonstrating, you can try it out yourself. So what I do here is I already have, let me show you, vote-rs. The convention that I use is the name of the application hyphen the object. RS stands for replica set here. You can see that the replica set has the properties. The spec contains replica set, selector, template. I don't have minimum ready seconds yet because I need it only during deployment. So I have the rest of the properties, template, selector, replicas. I can use this, reuse this code, and just add the strategy part and maybe min ready seconds, and that should give me a deployment. So what I do here is I copy this over because I'm just going to convert this into a deployment. So I keep this existing code and then I make a copy of it in the form of vote-deployment.yaml, which is what I am now editing. So since I'm converting it into a deployment, the object is no more the replica set. The kind is not replica set. It will be converted to deployment. It's like the API version and everything is same. I convert the kind to deployment. I will also change the number of replicas to 12 because I want to show you at least 3 to 4 batches being deployed, rolled out. So I change that to 12. And then I add a couple of properties. One is as part of deployment spec, we have these properties, right? One is a strategy. Second is I also need this min ready seconds. Min ready seconds is the interval it waits between 2 batches. So I'm going to say 20. I don't have to define the unit because it's already in seconds. And now I just have to add the strategy. Strategy contains what? Strategy contains 2 properties, type and rolling update. Strategy has type. Strategy has rolling update right here. So what is the type? By default, the type is anyways rolling update. I'll keep that as is. Yeah. So when you define this as a value, it's in capitals. So R and U both. But when you use it as a key, when you define rolling update, you can add the properties to the rolling update, namely max search, max and available. When you define it this way, it becomes a camel case. So R is in small letters. Observe that. Max search, M is in small letters, S is in capital letters. Max search, max unavailable. What is the surge? And you can, by default, is 25%, but you can define it as an integer. Max unavailable is, again, I'm going to say 1. I'm creating a surge of 2, same as my example. Unavailable is 1. And this is actually a deployment, actually. So you take replica set. That's why we learn it step by step. So we started with replica sets and we spent some time understanding the spec there, namely selectors and template and stuff. And once we understand that, now we just have to think about strategy. That's it, mainly. Right? There are other properties like this, but mainly the strategy where we have rolling update with a surge of 2, unavailable being set to 1. And now I'll use this to roll out or deploy my application first. Before I start with the newer versions, let me also see what version I have. V1 is fine, perfectly fine. So let me apply this vote-deploy.yaml. Now what happens if you observe, You're going to see something interesting. One is it's launching its own set of pods. That's this deployment called as vote. And deployment vote has created a replica set for itself, which is this. This is where it has set the number to 12. I had created a replica set independently earlier called as vote. Now I don't need it because that replica set has created these pods. Deployment has created 12 more pods. And deployment does not take over the existing replica set. It has its own set of replica sets. So I have to delete the previous one. So I will go ahead and delete the previous replica set just to clean it up a little bit. And I just need that one thing, and that's all. And I will start watching for, I want the labels as well because I want to show you what version are being deployed. And then I will filter by role vote. Okay, I'm going to put all of this into a watch command. Okay. Going to just bring the visualizer, which is nothing but this application on the sites. All right. So you should see what's going on with this application on the right-hand side. You see all these pods running what application. There are like approximately 4 running on each node that is available. In my case, I have 3 nodes plus 1 control plane node available here. What are the things that you're going to watch for when we start rolling out this application? One is you would watch for the deployment. Here you will see the ready being surge being available. So you'll see 14 out of 12 instead of 12. That would be the surge of 2. Unavailable, maximum unavailable is 1. So available will never fall below 11. So you're going to see that. Up to date depends on which one is the newer version, which one is the older version. Right now, everything is with V1. And you're going to see a new replica set created by this deployment every time there is a rollout. So observe all of these things. The surge here, how many are available, what is the configuration here, and I will start rolling out from another terminal. And here I will also show you one more thing here, that is rollout status for this deployment whose name is vote. We will see something happening here as well. And the batch size, basically, you'll see it once I start rolling out. How do I roll out now is very simple. Just change the image or some configuration, in this case, just an image mainly. And I will also change the labels just to for the information, so that we know what version is being deployed. And then I apply this and it starts rolling out, which is what you will see now, rolling out with a batch of 3. You're going to see that on the right as well. 2 created as part of surge, 1 was taken down, and you do see a surge batch of 3. So it has created a new replica set. See that now? Just a few seconds ago, this was created. 3 have been rolled out. Surge of 2, so 14, available is 11. a new rollout just happened. You see that on the right, you know, and this has gone up to 6. So 6 are up to date, meaning the next batch. Yeah. So batch of 3 again. So it's gone from 3 to 6 now. Surge of 2 available, up to date, a new replica set. Keep observing. Every 20 seconds. So there's a gap of 20 seconds. That's the min ready seconds. So every 20 seconds, there is a new rollout. So the third rollout just happened, gone to 9. And keep observing all the parameters here. Yeah, and the next batch just been rolled out, and it's just waiting for these two to go away now, the previous version. So that will bring it down to 12. So it's just waiting for 2 old replicas for pending termination. That's why you see this message. So it's gone from 3 to 6 to 9 to 2. And once that gets deleted, it just happened. You saw that change here. And since this has gone to 0, this 12 replicas is what we need anyways. So 12 out of 12 are running with the new version of that application. Let me demonstrate this one more time. We'll do it a few times so that you see what's going on. So let's say I go to v4 now. Let me also show you one more configuration here. kubectl rollout status is what we saw, but rollout has few more commands. You can look at the rollout history. You can pause a rollout. You can resume a rollout. You can restart all the pods in a rollout, as in you can recreate the pods. There is no other way. There is no way to run kubectl stop pods or something like that. So you can do restart, which will delete the pods and create it again. If you just want to refresh the pods for whatever reason, you can use the restart for that. Status, what we saw. Undo, we're going to explore. That's for rollback. And restart is all the pods. And pause and resume are related. So you can pause the rollout and resume it later if you want to. I want to show you the history of the rollouts. History of the rollout for deployment, whose name is vote. And what I want to talk about here is the change cause. One is you can see the history. You can also look at, specific revision. What went into revision number 1? The configuration. Revision number 2, that configuration. And there is something called as the change cause. Now, this change cause, how do you add it is by adding something called as an annotation. So we have labels. Labels are identifying metadata versus annotations are not like you don't use annotations for identify a set of pods. Like labels you can. So you can say that, I want to find, and that's what I'm doing here. I'm listing all the pods with only role vote. I have Redis, which is not being, which is being filtered out, right? It's just only filtering whatever the pods match this particular label. So label that way is identifying data. It's like your name, right? So you can identify a person with a name, right? But apart from that, you may have some attributes like, and all of that properties you can add with annotations. You can also use annotations for various other things. But this is one use case where you can add this as an annotation, more like an information, and you can annotate a deployment. I'll show you how. A couple of different ways. You can do that using a command, using an imperative way. Actually, let's just look at Kubernetes deployment. We'll find annotation automatically. Are we there on the search? Interesting. All right. Yeah. So you can use a command like this to annotate a deployment. what will happen is it will update the last revision and the change cost for it. So revision number 2. So I'm gonna annotate. I'm just gonna change this a little bit using my style. So there are multiple styles you can use. You can use this and say deployment slash vote. You can use deploy slash vote. You can use deploy space vote. This is what I typically use. So I'm gonna change it to this. This is the annotation. This is the property that you add. You can add any property that you want. In this case, it's reading the change cause, and we'll say updated image updated to be 2, v3, v2, v2. Okay, that's my last change cause. You can see that it's been added. Now, this is one way of annotating a deployment. The other way is to add this as a property, So how would I do that is I can use this YAML to add the annotation. Annotation is a type of a metadata. It's part of the metadata. So you can see that it's from the spec here. You go to any spec, you will find the annotation. Let's say deployment has metadata, object metadata has annotation, and one of that is labels, another is annotations, right? So those two types of useful metadata that we have. And in this case, I will add annotations to the metadata, and this is the annotation that I want to add. When you add it this way, you can't use unlike the annotation command, which use something like this, we have to follow the YAML syntax that Kubernetes uses, including 2-space indentation. And I will just say, okay, updated image to, all right. Now I'm gonna say v5. I probably haven't even applied it yet. So let me just say v4. So when I apply the change now and roll out, so currently it is if you look at the history of the revision, you'll find exactly which one it is. So currently image has been updated to v2, that's what it is. We're going to apply the v4, the change with the annotation and this time. So if I apply and look at the status, you're going to see the same thing. So batch of 3 just been rolled out. You see that on the right, reblinking. Batch of 3 just went out. It's going to wait for about 20 seconds after these become ready to roll out the new version. You're going to see everything again. So you have a new replica set, yet another replica set created to maintain that version 4. You see the rollout, just one more batch just went out. So it's going to go from 3 to 6 eventually. There's a surge and there are two different properties, surge and max and available. So sometimes it happens in a batch 2 and 1, 2 and 1, something like that. But you see the surge, you see the available, this never falls below 11. You do see this is growing, this is shrinking. It just shrank by 1, probably 2 more. Right, so it's happening in the batch of 3, but in a different step. So it went from 5 to 8. And it's following the same thing now. What you're going to see throughout this case is the application never goes down. So if I have the application available here and put it on a refresh or something, you're going to see the application being available all the time. Sometimes v4, sometimes v2. You're going to see v2s as well. We still have that. Yeah, so you see v2 on the right. You see v4 now. More of v4s, less of v2s, eventually all v4s. But the application never goes down. So that's what the deployment ensures. Okay. All right. Okay. If you have any questions, you can put it in the chat. I am just reading the comment. I see there's one comment from Janice. Is it possible to make the video shorter? Shorter would mean we cover less topics, less number of topics every week. And I understand it's a bit harder to follow everything, but you can probably do it in bits and pieces, or you can just be part of the membership program where we have this as available as part of a course, which is a shorter, like, videos, 5 minute, 7 minute videos, and you can take it by chapter. Here we're like covering 2 or 3 chapters at a time. But we'll have to do that because we have to be on track with our program. And in 3 months, we have to cover this much. Next time, I'll probably try to remove things which are not essential and make it a shorter program so that we can go in a pace which is more comfortable for most of you to follow. That is something we can do, but we'll have to do it next quarter. We have to cover this as per the plan, whatever the topics are, and whatever is for CK and CKAD, we will cover it anyways. All right, so this V4 has been rolled out. If I show you the change cause, you are going to see that here in the rollout history. Now you see the revision. This is the third revision. It has nothing to do with the actual version, okay? This revision has nothing to do with the actual version. This is just a sequence in which the rollouts are happening. And that's why if you look at revision details, you have image being set to V4. That's revision number 3. Now, how these revisions are maintained is via the replica set. That's why you have these many, 3 revisions, 3 replica sets. How many replica sets will be maintained? For what purpose? The answer to that is here. You can see there is a property. One is called as the revision history limit. So what it says or what it reads is the number of old replica set to retain. For what? To allow the rollback, basically. So you can roll back without worrying about what configuration went in that point of time, right? And this defaults to 10, basically. So you can go back 10 times with this configuration. Let me just put my phone on silent. Using the rollout revision history limit, basically, right? That's what this is for. Now, you can change it. That's why the default is 10, but you can change it if you want less number of revisions. And how does this rollback happen? What happens if there is a problem? Let me show you that as well, right? So I'm trying to roll out a new version, V5. That's what I would say, but I would break it now. I'm just adding an image which doesn't exist. Try to apply. Look at the status. It has rolled out the first batch. You see that. Now, what happens with this first batch? Just create a new replica set to maintain that revision again. What happens to that set of pods, though, is it is in the error stage, pulling the image. There's an error image pullback, and that is a problem here, right? So what happens in such case is it's going to try and just assume that Kubernetes is recreating and assume that at some point of time it would come back up. If not, it is going to wait for about that's why this is another property, progress deadline seconds come in, because it says wait for like 600 seconds and then mark it as failed, but it will not roll back on its own. You have to do that in case of just plain Kubernetes, vanilla Kubernetes here. How do I roll back, though, is I can look at which version I want to roll back to. Let's also find out what's happening here. So let's see history. So we have 4 rollouts so far. The latest revision, which has a problem, is version number 4. Revision number 4. The problem is here. We can go back to this revision number 3 as well, where we had V4. If you just want to go back to the last revision, last working, you can just say kubectl rollout undo, and then say deploy vote. It goes back to that revision, okay? Meaning it just had to replace the 3 pods which had a failure, and it all goes back to this replica set. Basically, it's just switching between replica sets, right? With undo, it just switched back to the last replica set maintained by the last revision. You can also go back to a specific revision. Right now it's on v4, right? So you can see that that's the one. You can also go to a specific revision here by using revision number. I can say revision number 2, whatever was there, 2 revision actually. And it goes back to that revision. Okay. So it goes back to that revision, revision number 2. You see, the way it works is it's just gonna take you back to this particular replica set. This replica set was created 16 minutes ago. This is the latest one, which has a problem. From there, it went to the last revision, a version before that. And now we're switching to this one. And it's just switching between the replicas. It just launches same strategy. It just goes in batches of 3, and it is going back to the revision number 2 slowly and surely. And that's what is happening here. Every 22nd, a new rollout. And right now I have 9 of these V2s and 5 of V4s. So you will still see V4s a little bit, but eventually it will all go back to the V2s. That's what you're going to see in few seconds after this is done, that, the rollback is done. So we're doing a rollback using this undo command with deployment, basically. So rollout undo is for rollback. This is how you roll back to a previous revision. Okay. Again, are there any questions so far? Especially if you're appearing for CKAD exam, the application developer exam, these things are quite important actually. And even for CKA, understanding of deployments, a bit of troubleshooting, rollbacks, how does it work, are definitely useful, right? So that's where this topic comes in. So we talked about deployments. Deployments offer you this ability to roll out a new version and also rolling back. And it's a very simple topic because once you understand the replica sets, it is just a matter of understanding the strategy, mainly, where you have this max and available max search. How does it work? I showed you with the visualization and demonstration both. And then we have other properties like revision history limit, progress deadline second, to mark it as failure. Revision history limit is to maintain X number of replica sets. Why, how, we just saw that. We learned how to deploy or roll out a few versions. We learned how to roll back as well. And that's pretty much about the deployment topic.
Got it.
Topic, once you understand replica sets. Yes, Pradeep, go ahead.
Quick question. Sorry, you probably must have covered. I had to step out for a second. So when you are rolling back, right? So for some reason the old image was not available or something happened, then it may fail the rolling back. So what kind of situation you will end up in that case? You will still get the latest version, or like it is just what happens?
So if rolling back, generally rolling back, these kind of things should not happen. But there is a rare case situation where there is a problem on that system and it's not able to pull the image or whatnot, because it should have been a successful rollout in the first place, right?
Yeah, that's correct.
We are assuming that. But let's assume that the image had been removed from the systems as well as from the registry. And what happens in that case is it's rolling back also in the batch of 3. See, when we started, you're going to start with, let's say, batch of 12. So there are 12 pods and it creates a surge of 2, replaces 1. So, 3 odd things have a problem. And because of that, you're rolling back. So wherever you started from, you are going to have 11 available at that point of time, right? And let me apply this.
Okay, that availability will take care of that. So,
yes. So 11 is available, right? So 11 are available. What happens beyond this is it's not going to go to the next pod at all, because now it does not have that headspace, because that max unavailable is exhausted. So it has to maintain 11 to be available. So these are not touched at all. Now, what happens if you start rolling back is it's going to the new another one. Let's say you're going right now, we're at V4 and you're rolling back to we were rolling out V5 where the problem was, but you still have V4 running, right? These are actual running pods. So let's say you're trying to roll back to V2 and your question is if V2 has a problem, what happens is these three again will be in issue, will be in problem, but remaining 11 is automatically taken care of. That's the significance of that max unavailable actually.
Yeah, that's correct. Yeah, got it. Got it.
All right. Okay, there is a question from the YouTube stream. What happens if the previous image of rollout has been removed? Yeah, I think it's the same question. So Vivek has the same question, exactly same answer. So that's what we talked about here. So only 3 will be affected, but you still will have the minimum guarantee. That is whatever the desired minus the max unavailable. Desired in this case is 12. And out of that, max unavailable is 1. If max unavailable is, let's say, 25%, it would be around 3 pods again out of that may not be available, plus the surge. So maybe 3 or 4, 5 pods will be affected. All right. Any other question? Okay, so Ashfaqar has a question about how do we control traffic between these two versions, right? Now, what happens here is very interesting. It's a good question. Let me explain what is going to happen and how you can do different types of releases based on that. So you saw this happen, right? So you saw the replica sets. There are 2 replica sets, and those were maintaining set of pods, right? Now, who is routing the traffic is the service here. So you saw that service is routing to both the versions. So whenever we start a rollout, right? So let's say we go to a different version. And it's going to start rolling out, let's say V5 now. So you're going to see V2, V5s. So who is doing the application routing and how is that happening? Let's understand that. Let's wait for at least one V5 on the right. Yes, so you can see it's routing to both. How is this happening? Is via service. Now, as far as service is concerned, I'll show it visually. Yeah. So as far as the services are concerned, it doesn't care who has created the pods. It doesn't really care. Let's say these ones are maintained by replica set 1. Then you have a few more with replica set 2. What is service looking at? Who's routing the traffic? Who's routing the traffic is the service. Let's say this one. And this is your user. And then from there, it doesn't care about who created the pods. All service cares about in this case is the set of pods with certain labels. That's why labels and selectors, very important, because service doesn't care whether the pods were created just as pods, through replica sets, through stateful set, through deployment. It's up to you, right? So you can see that here, describe the service. And all it cares about is a selector saying that, oh, any pod which has this property, and this is where you're going to see any pod with this property, it just routes to it. Now, it doesn't care which version, because we don't care about the version in the selector. If selector said role vote and version X, then it would have only selected those. But right now, it has selected everything. So V2, V5 doesn't care. And that's why you see V2s and V5s, because service is the one which is routing to that. Now, if you want to do it in a certain way, like, and this is where if you want to implement, so Kubernetes has a limitation where it can only do rolling update like we see, or recreate with a downtime. Now there is nothing in between, right? And this is where you can bring in ergo rollouts or something like that. That's why we have that topic, where what you would do is you are going to have, let's say you want to do a blue-green release where your service is pointing to only version 1. Then you bring up another one. You bring up a preview service maybe just for testing, right? So for internal testing, you can use that. And then this service will be brought up, and you're going to have another set of pods. This is a blue green. So let's call it as a blue release. This is called as a green release, right? Now your live traffic is still going this way, right? And you still see only version 1, but v2 exists and it is being tested. And once it is done, you can run the tests and whatnot. What you do is you just switch the selector here. So selector here says role is equal to vote plus version is equal to v1. And you change that to say role is equal to vote and version is equal to v2. Immediately, what happens is this service then will start pointing to not these ones, but it will basically switch to these ones. And that's the time when you have v2 live. This is called as a blue-green release. So there is a blip of a switch. So maybe a blip of a downtime maybe, but very minimal. And then you delete these later. And this is the service which still everyone is pointing to. So this is how you can implement blue-green releases. And if you use Argo CD, Argo rollout specifically, it actually helps you strategize this, put this into YAML as well. So this entire strategy where you define the preview service, you define if you want to run any tests, you can do that. You can decide how much of time to wait before making this switch to this basically, and so on and so forth. That's what Argo rollout offers on top of Kubernetes deployment. And for this to understand, you need to understand how services work. So right now, services don't care about the version because that's how our selectors have been configured to. And they just send traffic to whoever is available with whatever version. And that's why you see this behavior. All right, that should answer your question, Ashfikar. Okay, Kunal has a few comments here. I'm just going to read through those. So Kunal says, I've tried deploying workloads using Kubernetes, coming from Docker plus Docker Swarm, Nginx, all right. I never get how to deploy end-to-end in Kubernetes, like from manifest to online with SSL issued and all that. I'm looking into Azure VM and Kubernetes plus Argo CD, some SSL stuff. Always get stuff at ingress. Yes, so Kunal's question is basically, how do you go from, let's say, end-to-end deployment with, okay, we're gonna go off topic, but that's fine. We'll address this question. So we have Azure VM. So Azure, the only difference that it will make is it has a managed application gateway. Okay, Azure has ingress. We talked about ingress last week. We used our own traffic deployment, traffic as a deployment, ingress deployment. But in case of Azure, what you're going to have is you have this application gateway or equivalent, which works as the ingress by itself. So how you're going to go about is you're going to have a deployment to run the pods or equivalent. You're going to have a service, right, to route the traffic to it and also serve as an endpoint collector, so that you're going to have an ingress here. And to the ingress, you will install, like as a user, you're going to configure something called as an ingress rule. And there you can configure the SSL basically. So you'll create a deployment, you'll create a service, you will have an ingress rule. That is where you can influence how the SSLs are configured, and you're going to have a secret where you have your TLS or certificate information, which is what will be invoked through the ingress. And that's what you will install here, basically. That is how you'll have to go about. I'm just giving you a very high level picture, but if you have any specific questions about it, you can let me know as well, right? And if you want to understand, so I just had a project related to this that I've given as part of this projects for ingress. One of the project is this, where you not only do the deployment, the advanced level of that is slightly SSL. So let's say this is an example of Nginx ingress, right? So here you have a couple of applications deployed just for testing. Then you deploy Nginx ingress controller. In case of managed services like Azure, I'm assuming you already have ingress controller, or if you're using Nginx, you'll have to deploy this. The key part about SSL is something like this, I think, right? Something like this, where you are, you start with this, and then ingress rule is important. This is the important part where I said TLS information will go in. So you will mention that, hey, this is my ingress controller. These are my configurations. And most likely this still doesn't have the, okay, it's probably doing some certification automatically in this case. You'll have to either rely on this, or there are, with Azure, most likely you're going to have a secret, maybe a certificate TLS there, and there you will basically have something, some secret. Yeah, you can see that the TLS is a secret for this. So you'll have a rule which is a variation of this. I'm just sharing this on the chat for a reference, and put this on the YouTube live as well. Yeah. So you can try this out, go through this, and then um, give this a try. And if you are a member, we generally take these kind of questions and we address those. We also do look at the solution for, we're going to look at the solution for this in this week's Thursday session. We call it as the inner circle call. So we generally take this up, look at the solution, discuss the solutions, and that should give you a lot more insight as well. So you can, if you're a member, you can join the sessions and bring in this question, bring in your setup. We will look into this as well. Right. So that's Kunal's question. Anyone else has a question on deployment so far? Okay, this is also a good use case for secrets, by the way. Anyways, we'll talk about this configuration part a little bit. I'm just going to talk about config map, but secret will just touch base on it very briefly, but I'll help you understand how this works because both are quite similar. So let's say you have deployed the application, you want to provide it some configurations. That's where you can either provide just like environment variables or something. Sometimes it's configuration files. So you can create a dedicated configuration object called as a config map, and then invoke it from your manifest, like your deployment spec or pod spec mainly, or a container spec to be very specific, right? I'm just going to give you an example of one such use case here, where let's say this application that you see and these options that you see, how they are handled, let's look at that. So we'll look at the application very briefly and look at how it is handled. So this is the application, the Vote application, and you see the app.py. And here it's actually just looking up the option via the environment variable, option A and option B. So if you define the environment variables as option A and option B, it will read that. If not, it is falling back to whatever you see right now. So whatever you see right now are just fallbacks in lieu of the environment variables. Let's suppose I want to define the environment variables. What could be the best way to do that? That's where config maps can come in. So you can define the environment variables. You can define the config files as well. I'll show you the environment variable option, where let's say I have this config map that I'm going to create. In case of config map, if you look at the spec, instead of AKMS, it has AKM and D for data, because it doesn't need any spec. It's just a configuration object. So you just define the configuration. So in case, if you look up config map API reference, it is basically, there's a list of config maps, and then it's a config map here. Yeah. So it is API version, kind, metadata, and either it is data or binary data. And then you have one more property, whether it is immutable or not, basically, right? Which is good. This immutable thing is good because now whenever you change a configuration, if you set it to immutable to false, it will roll out basically a new version. Now, how do you provide this? This is an example. So config map is just an example like this, where I'm just adding a configuration map with this name and data being option A and option B. This option A and option B is what the application reads, right? This application is just reading that. We just saw the code here. And it will display that if it finds the environment variable, option A and option B. Let's create one. Creating a config map. All right. And then so you can see the config map here called as vote. A couple of data points in there. So a couple of environment variables, which I can describe here. Yes, this is a config map with this name in this namespace. Option A is set to this Visa. Option B is set to MasterCard. There's no binary data here. And now that I have this config map, how do I reference it is where I go to my deployment and I add a reference to the config map. Now, how do I do that? Let's find out. It won't be part of a deployment. Deployment deploys the pod set of pods. So it will be part of pods or not even pods, because if you look at the pods and look at the spec here, right? This is alphabetically ordered. So to look up the environment variable configuration, we go to E. There's nothing here. Why there's nothing here? Because it's actually a set of containers the pod deploys ultimately. And every environment variable will be specific to a container. So you have to go to the container spec. And in the container spec, you will see a couple of those properties, env, where you can just define the environment variables, key and values, or env from, which can take config map or a secret. Secret is just a opaque data versus config map is plain text data. That's the key difference between the two. Secret will be opaque. So if you have keys, credentials, API keys and stuff, you may want to use a secret there. Even TLS certificates, you can use a secret there. Config map reference is what we want to add here. And it will be basically part of env from. So I'll start adding that property and show you how this can be added and where. So it will be part of this vote applications spec, template spec. Template is the pod spec. And here we have container properties. Container properties are right here. These are the ones you see as being container properties. And then we add env from, and env from is an array. Config map reference, right? And then I add the name and optional, whether the name of the config map and whether the config map is optional or not. Name is vote and whether it is optional or not, right? Why optional is because sometimes we have a code. This code is resilient, as in if the config map is present, it's fine. If it is not present, that's also fine. But sometimes it is mandatory to have the configuration map, in which case optional will be set to false. Right now, we can just set it to true or just leave it as is, which means it is anyways optional, right? So env from config map, it's not optional actually. The default should be true. It's not optional. Anyways, so we say environment from config map reference and provide the reference to the config map here. And now I will just roll out with this property now. And it does the same strategy, rollout, and all that. All of that is similar. So that's what you're going to see here happen. And it starts rolling out. And eventually what you're going to see is it reads it from the config map now. Instead of these options, you're going to see these ones now. So whatever has been being rolled out with the new version, you are going to see those options which are coming out of the config map only. Right. So that's how the config maps work. And this is just one small example of the config map. You can also provide the entire configuration file as a config map. That's also possible. And secret is just similar data, but it's in opaque form. So you don't see the actual data that is being masked from you. It is encoded version of the data, right? So you can use it to store, let's say, anything that can be stored as plain text, like TLS certificates, keys, any secret information, passwords and stuff. You may want to consider secrets. It's not completely foolproof. You can also use further some technologies like HashiCorp Vault. You can integrate that with Kubernetes to make it even more secure, actually. Right, so that's how this works, actually. And that's about very brief, about config maps and secrets with one example. I'm going to share these labs. This is the one with for the secrets and config maps. And the deployment lab is right here. This is the deployment lab. Yeah, if you're a member, you'll get the recordings along with the same lab guide that you can follow. And here it goes. Again, any questions for today's session so far? These are two topics we wanted to cover anyways. So we'll take the questions and then we will, kind of wrap up. Next week, when we come back, we're going to take up the next topic about persistent storage. In the meanwhile, I have uploaded the projects till the ingress and network. I would upload the deployment projects this week by, let's say, Thursday or max Friday, and both deployments and config maps for the members who have access to the project library. You will have at least three to four projects on these topics as well. Right. Okay. There's a question from Ago. Can we do the deployments of all the microservices and see how all fits in? Well, you need a deployment for every single microservice, right? So you can't deploy all at once. Every application will have its own deployment file and then you roll out. If you want to roll it out together as a application stack, you better look up some options like Argo or Flux CD, where you have a choice of setting up dependencies between applications, sequencing those, doing rollouts for multiple apps and stuff like that. You can also use Hem as a packager for your application. We'll talk about Hem. We will be talking about Argo CD in the weeks to come. And at that time, Hem definitely will cover some of these topics, like how do we take multiple application and the code for that and put it together. And then you can sequence it possibly with something like Argo CD there. Another question from Vivek is some size limitation is there to pass with config map. I would have to look up, especially binary data. There should be some size limitation. Let's see if we can find something here. For text data, it won't be like, you're not going to have like GBs and GBs of data for text. If it is a binary, yes, it makes sense to have some sort of a limitation there. Let's see if we can find it right away. So config map as a binary data, which is an object. All right. There is a specific version of API server. I will try to find out what would be that limit for, let's say, the binary data. That's where I believe the limitations would be in place. Okay. There's a question from Femi. Could this rollout be done using GitOps in a live prod? Yes, of course. That's where these tools like Argo CD and Flux CD both are GitOps tools. And GitOps is more about you take the code and put it in Git repository. You set up the workflows there, and the GitOps tool like Flux CD or Argo CD just reads the changes in your Git repository. That's your manifest, the code right here. And that gets deployed automatically to your actual live environment. That's what GitOps really is all about. So it's just an extension of what we are doing here. So we write the deployment code, the services, and all these manifests, decide how we want to package it using hem, customize, so that we can create different configuration profiles for different environments, and then let GitOps do the rest of the things about the actual automatic deployment. Whenever we make change in the code, it should go and deploy it automatically. That's what GitOps is all about. So yes, very much. GitOps is something you should consider using for automating these deployments. Chana has a question. Do we have any support email contact to reach out if we have payment issues when purchasing the membership program? I will share the support email. You send out the email to this particular ID, and we would be glad to help you out with that. Right? So just use this email to get in touch with us. All right. Any other questions right now? We talked about deployments, we talked about config maps, and we will take up storage. Again, we have a bunch of concepts there: persistent volumes, persistent volume claims, storage classes, provisioners, a new stuff that is CSI, container storage interface. We'll talk about stateful sets and daemon sets. And then we'll go on to talk about security, hem, production setup, administration, and Argo CD, which is nothing but the GitOps tool. All right. So the last question I see from Femi is, all these videos are on the membership, but these videos are also available on YouTube Live. In the membership on the portal, what you will find is more of a course format where each of this topic is broken down into, let's say, a chapter, right? So for example, there's a chapter on deployment where there are multiple lessons. And I'll just show you. This is plus you have projects, access to the projects as well. So there are a bunch of projects already there. So we have about 4 into approximately 15 projects are already there, and we're adding more every week. And as far as the course is concerned, this is the Kubernetes course, which is a very detailed course on everything that we talk about here, plus a lot more, including, let's say, if you look at deployment, that itself is a chapter in itself, right? Deployment is one chapter. This is all about deployment, and plus the previous page, part of it, configuration management and secrets is here. Persistent data has its own chapter. So it is basically a chapter by chapter, lesson by lesson learning that you do, plus you come back and do the projects, and that's all part of the membership. In addition to these recordings are available to everyone. You don't need to be a member to do so, but with membership, you get all these additional benefits, plus access to the weekly calls where we discuss things and, figure out things, and also talk about the projects and do the presentations there. So you get more learning out of it. All right, with that, we will conclude the sessions here. So thank you very much. And I will see you. For those of you who are joining live from live stream, I'll see you next week with the next topic about persistent storage. If you're a member, I'm going to see you on Thursday with our Inner Circle call, where we'll take up the pending projects for the couple of weeks and talk about those and more interesting conversations. So thank you, and all the best with this mission, and I'll see you then. Bye-bye.
Thank you.
Thank you.
Thank you. Bye-bye.